It's day 1 of chapter 6. We're going to do the slope of a line. Now here you have 3 images of 3 different homes. Now in Canada, the homes typically have this orientation where it's like triangular or sloping roofs. Why, of course, do we have sloping roofs? Yeah, the snow. You don't want the snow to be piling up on a flat surface. And, you know, if you go to warmer climates, like if you're going down to California or something, or even like if you're in Mexico or anything like this, typically the houses don't have this shape to them. They don't actually have this shape. So, yeah. Anyways, calculating slope in like layman's terms, just like everyday language, it would be the rise divided by the run. So rise over run is a really common phrase that you can help to remember. Like rise goes which way? Up, and then the run will be the horizontal. So it's the numerator divided by the denominator. Do you want just a pen? I have a pen. Is that okay? Okay, so let's take a look at roof A. All you have to do, you guys, all you have to do is count. Count the unit squares. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. And the run, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Okay, and that's why they have here 13 over 13. Of course, you're going to want to take all of these ratios to either a lowest terms fraction or a numerical value like a decimal. So all you have to do, you guys, punch it into the calculator, get the numerical value for the slope. The only other thing I would mention is maybe for the last one, you can reduce to lowest terms as well. All right, so don't forget you can do that. Now just by looking at these pictures, which roof appears to be the steepest? Roof C does appear to be the steepest. Now look at the numerical value for C. It is larger than the other two. So in terms of steepness, it's all about the magnitude or the size of the slope. Okay, roof C is steepest because its slope is the greatest. So make sure you give those a quick read. Now, this slope formula, rise over run, which is the change in the y component divided by the change in the x component, it's going to have a more formal definition given here. This is what we're going to have to work on today. So y2 take away y1, that is the change in y. So that's delta y. And x2 take away x1 is the change in x. In science, they sometimes would call this like final minus initial. So like in a science class, let's say like your v final take away your v initial divided by time. What does that equal? Do you recognize that one? Acceleration, right? So it would be the change in the acceleration, or pardon me, the change in the speed divided by the time. So this is no different. Final minus initial. You could think of it as, you know, the second one take away the first one. So the second point take away the first point. And you have to be consistent. Do you see how it starts off with the 2's first and then the 1's? You have to have that consistency. You can't go y2 take away y1 and then x1 take away x2. It has to be consistent, like 2's first, then 1's. Okay, so this one here, we're just going to do a quick sketch, but we're going to use the formula. So where would 2, negative 1 be? Which quadrant would that one be in? 2 to the right and 1 down, you would be right here. That would be quadrant 4. That's point A. And where's point B going to be? 3 to the right, but 4 up. And then all you have to do, you guys, is connect those 2 points. And then we're going to do the slope. We're going to do the slope calculation for this. Okay, so we have A, and we have my bad, we have B right here. So if you were to assign one of those to be the first point and the second point, what would your natural gut feeling tell you? Which one would be point 2? B because it's B, or B because it's to the right? I would call B the second point because it's farther to the right. So anything farther to the right, I call the second point, and then anything closer I would call the first point. Okay? So A is 2 comma negative 1, and B is 3 comma 4. So when you go to use this formula, M stands for slope. You gotta do y2 take away y1 over x2 take away x1. So y2. Where do I grab y2 from? So it's the second point. And then which one's the y? The 4. And then where's y1 going to come from? The first point. And which one's the y? The negative 1. Now you see how you're subtracting a negative? Don't let that mess you up. It can and often will happen in your homework questions and your test questions, so don't let that mess you up. Okay, now where's the x going to come from? Where's the blue x for y2? Where's this one going to come from? 3, right? And then where's the green x going to come from? 2. And then in the black ink is everything that has to be there from the formula. The black ink is the formula. You notice the formula has a subtraction. It has a subtraction. So you have to put subtraction in the formula. And then where you see the brackets is where I subbed in the actual points. Now you can get a little bit lost in that formula, couldn't you? All the minuses and stuff, right? But I need you to be thinking logically. Like, let's take a look at the y. What happened to the negative 1? It became... What did negative 1 become? 4. So what was the change in y? Think about like the temperature. If it's minus 1 degrees outside, and then it's 4 degrees outside, how much did the temperature change? 5 degrees. And what's 4 take away a negative 1? Well, those two will make a plus. And 4 plus 1 is 5. 5 is the delta y. Do you see that you've gone from negative 1 to 4? You've gone up 5 units. What about the delta x? You started at 2 and then you became 3. So how much did you change by? 1. And 3 take away 2 is 1. 5 divided by 1, of course, is just 5. So the slope of this line is 5. Now I'll give you another strategy where you don't have to sketch it out and think about it. If you were to just follow the formula, connect the y's and connect the x's, I would call this one point 2 and I would call this one point 1. Not for any particular reason, just because this one showed up first and this one showed up second. So this would be just like follow the formula. That formula will be given to you on your data sheet. You don't ever have to memorize it, but you know, you do enough of these, you will memorize it. So where's the y2? Well, I got to look from point 2. And which one's the y component? 7. And then I need to subtract y1. Well, which one's the y from point 1? 7. Now I divide it by the change in x. Which one's x2? Negative 3. And I have to subtract 0. Well, the top number is 7 take away 7, which is 0. And then negative 3 take away nothing is negative 3. So what is 0 divided by anything? 0. So this slope is 0. I want you to think about why this slope would be 0. Like, you started at, for the y is 7, and then this next one is 7. What would that look like? A horizontal line. This one is 0, 7. And this one is, oh, it's the other way. This one's negative 3, 7. So while the x changed, the y did not. So when you think about the rise over the run, the rise was 0 and the run was 3, or whatever. You get 0. So a slope of 0, that's a horizontal line. And we'll see that shortly as well. But we can jot it down now if you like. Slope of 0 is horizontal. Okay, let's just do one at a time here. So now this one, you're given a point, and you're given a slope. So you have a point and you have a slope. Could you generate another point? So 4, 5, plot that point. Just from marking your exams, there are still a few people in here that do struggle with the graph situation. 4, 5 would be 4 to the right, 5 up. Now, how could we generate the next point? The slope is 3. So what does that mean? 3 is equal to rise over run. So which one's the rise, which one's the run? If it just, it's not a, you know, like this one, the half, that one's a lot easier because the run is 2 and the rise is 1. That one's easy. But what's going to happen here? I think the rise is 3, but what would be the run? Good. It's a 1. Because 3 divided by 1 is still 3. So this is a special thing, like, make a note of this. Integer, put 1 underneath. It'll help you. Okay, if you're given a slope that's an integer, just put a 1 underneath. Your life will be a lot easier. So this means that the run is 1 and the rise is 3. So if I go over by 1 unit, I got to go up how many? That's a change of 1. That's a change of 3. Now you take your ID card or your phone or any flat edge side of your eraser, any flat edge, and then you connect. Make sure you hit the 2 points. And then remember that these are equations, so you can put these arrows on. Get in the habit of putting those arrows on in the math class. In the science class, you don't need the arrows. But in math, you do. Okay, let's try this one. If the 1 is the rise, then the 2 would have to be the run. And where do we start? negative 2 comma 6. Where is negative 2 comma 6 going to be? The 2 tells you it's to the left, and then the 6 tells you up. So we're up in this quadrant, top left. Remember, the first coordinate is your left and right. So left is negative, right is positive. And then the second coordinate is up and down, so positive and negative. So 2 to the left and 6 up. Now it says the run is 2 and the rise is 1. So I got to go 2 to the right and then 1 up. Once you have the 2 points, you connect with a straight edge. And then in the math class we put on the arrows. You guys think you can handle that? That's not too bad, right? So that's 2 and 1. So which one of those lines is steeper? Why is the first one steeper? Because 3 is greater than 0.5. So this one's steeper. Okay, so I'll let you guys try example 3. This one's on you. So you got to start at the point 1 comma 2. You guys started here? And then what does the slope tell you? 2 over 1. So it's 1 to the right and 2 up. So right there is 1 to the right, 2 up. 1 to the right, 2 up. 1 to the right, 2 up. Now think about this for a second. If you go, this is important to understand. Maybe just, if you go 1 to the right, 2 up, what happens if you go 1 to the left? Like 1 to the right, you'd have to go, to stay on that line, you'd have to go 2 down. Okay? Now, how many of those points do you need to make a line? Do you need 5? No, you just need how many? Just 2, yeah. You guys okay with that? So I maybe make a note here. If you go 1 right, 2 up, you could also go 2 down from 1 left. So the way I think about slope, especially for a science perspective, whatever the y-axis is, often the experiment has to do with time. So you think, as time goes on, you know, are you going up or are you going down as time goes on? So as you go to the right, that's what I'm always interested in. I always say, okay, as the run goes to the right, and because this is a positive 2, we go up. If that said negative 2, we'd go 1 to the right and 2 down. And we'll see that in the next example here. Okay, let's do question B because it's a little bit different. You want to find the slope here. So you want to make those triangles. Or what we can do, you can see it like, I'm guessing it's going to be 1 to the right and 2 down. 1 to the right and 2 down. So could we prove that using that formula? Because I think most of you could handle that triangle. Let's see if we can use that formula. So what's the point for C? Negative 3 comma 4. Good. And what's the point for D? You got 2 to the right and 6 down. So which one of those points would you call the second point? Which one's the second, C or D? Yeah, I would say this one's the second point because it's farther to the right. So what's the change in the y's? Negative 6, take away 4. Remember, you have to do the y's first. And then we're going to divide 2, take away negative 3. we do the x's second. And we always start with the second point. So we started with -6 in the top, and we started with 2 in the bottom. And then we subtract, always subtract. Y goes first, 4, and then x goes next in the bottom. All right, so -6, take away 4. You owe $6, you owe $6, and then you have to owe 4 more. So altogether you owe 10. And then the next one, when you see a double negative, you can think of it as a plus. So that's 2 plus 3, which is 5. And then a negative divided by a positive. And then it reduces. Reduces to the lowest terms fraction. So we can see here that it's 1 to the right, but 2 down. So the bottom number is, I'm going to say, if you do this, the bottom number is always to the right. The bottom number is always to the right. And then the top number, if it's positive, it goes up. If it's negative, it goes down. If you're always going to the right. Okay, and that's exactly what we suggested. It's 2 down, 1 over. Like if I was given this question on the test, I would not use the formula. I wouldn't. How much does the x change by? You could count that up, couldn't you? Couldn't you count that up? And then could you count how much the y changes by? Could you not just make a triangle? So how much does the x change by? It goes from -6 all the way to 4. How much does that change by? 10. And we went, did we go 10 to the right? We did, right? So is the graph going up or is the graph going down? Starting at A. You went to the right and then you went up or down. So this is positive. So how much did you go up by? 6? So then you would just go rise over run is 6 over 10. You could reduce that fraction. They both divide by 2, right? So 3 over 5. That's the slope. It's 3/5. If I was given that on a test, I likely wouldn't use the formula. But if I was given 2 points like this, I would probably just use the formula. Because I don't want to have to sketch that out. I'd probably just use the formula. But if I was given a picture, I would probably just draw a triangle. Here's a nice little summary page for you. The first example is positive slope. You can see that as x moves on to the right, the change in y is up. You know, contrast or compare that to this one over here, whereas the run is positive, so the change in x is positive, but the graph drops. So the rise is negative. So this is a positive slope and this is a negative slope. And you can see it's as the run is positive, as the run is positive. So that's a good like setting to always have your brain in for this type of stuff. Keep the run positive. What happens as you go to the right? This one we already encountered. What happens when you have a positive run, but the y doesn't change at all? So you have a horizontal line, and because the rise is 0, it's 0 divided by the run, which is 0. And we talked about those. Remember when you, in those examples where like you're driving your car, but then you're on a break, you're at rest? So we've talked about those ones. The distance versus time, where the distance doesn't change, you're at rest. So that means your speed is 0. So we've talked about these ones. Now we also saw these undefined slopes. A couple of you noticed and you told me it's like, that doesn't even make sense. It's like the water in the bath is rising. Then you're at rest. And then suddenly there's a big spike like that. You remember that quiz question? That's impossible. Some of you mentioned this to me. You're like, how does the water level rise in no time at all? Well, that's impossible. It's impossible. You can't do that. you need some amount of time to go by. So that's why they call this undefined. So this is the, yeah, you're going to want to definitely highlight this, undefined. Because what ends up happening is when you go to do the formula, you have some change in y divided by nothing. And this is impossible. You cannot divide by 0. If you try it in your calculator, you get the divide by 0 error. So like try 5 divided by 0. Have you guys ever asked Siri to divide by 0? Yeah, go for it. Everyone else can be quiet, we can listen to it. Say, what's 0 divided by 0? Alright, so we just have to do one more here. And this will be a discrete relationship. As you can see that the points are not connected, so this is discrete. And I noticed on your guys' exam, there's nothing to do with discrete and linear. There's no connection there. Okay? So just because something's linear doesn't mean it has to be discrete or vice versa. So don't make connections between is it linear and is it discrete. There's no connection there. Okay, well, what is the slope of the line through these points? So I recommend that if you're not given points, to draw the right angle triangle. How much does the x go up by? How much does the y go up by? The other thing I noticed on some of your guys' exams is you're not starting the origin at 0. Some of you put like 24 here at the starting point. The 0, 0 is the origin. You have to have your graph start at 0. And each time you go up, you have to go up by the same amount. Each time you go up in the scale, you go by the same amount. Okay? So how much did the x change by? 1 what? Unit is 1 hour. You changed 24 kilometers. So you have to include the units. So what does the slope of the line, what is the slope? You have 24 kilometers in 1 hour. You guys definitely recognize that unit. Kilometer per hour is obviously your speed. Now, like if you're going to the deli and you're buying like sandwich meat, you're not going to be buying kilometers per hour. What do you buy at the deli meat? Well, it would be like dollars per gram. Like maybe you buy like 500 grams of deli meat, dollars per gram. Or if you're draining a bathtub, maybe your liters per minute. So this can change. It's not always going to be speed. It totally depends on the unit. But when it says what does the slope represent, you can always be safe by writing this. That's the safe answer. Rate of change. So what are the units changing? How are the units changing? It's a rate of change. That's the safe answer. How can the answer to part B be used to determine how far Yvonne traveled in 1 3/4 hours? So what we can do is we can actually use those units to help us out. So 1 3/4 would be 1.75 hours. And we want to know, the question is what? How far? Which one of those units is how far? The kilometer, right? So what you can do is you can multiply by the 24 kilometers in 1 hour. And what do you notice happens to those hours? They cancel, and you're left in what unit? So 24 times 1.75 is 42 kilometers. And some of you will probably recognize this as, distance is equal to v, other way around, it's like t times v. the way I have it, but typically they write it as VT. So I'm just going to write it as VT. And then how does this connect? How does this connect to the math class? Well, this would be your y-axis. This is your slope, and this is your independent variable. Oh, I can't spell today. Independent variable. Dependent variable. And then this one would be the slope, or the rate of change. The slope is the rate of change. So the speed is the rate of change, which is the slope. So you guys, you take a science 10, you had to take the slope of a DT graph, and the slope of a DT graph was your speed. Okay, so the slope, VT, right? It's the same as TV's, but this looks better, VT. And then to answer question 2, the time it takes to travel 55 kilometers. So you would have to isolate for time. This one's not so easy to just do with the units. So what we can do is rearrange the formula. So if you know D is equal to VT, how would you isolate for T? Divide out the V, and you can solve for time. So she travels 55 kilometers, and her speed is 24 kilometers per hour. So you just do 55 divided by 24. You get like 2.3 roughly, about. But more importantly, the units. What happens to the kilometers? They cancel. But then look at this hours. Like, what is happening there? It's a divide. What do you think a divide is? It's like a negative makes a positive. A divide makes a times. It's like it undoes itself. Divide. If you divide, this hours is going to actually sneak up to the top. So it's 2.3 hours. Okay, so that's it. You have a lot of time to do your homework. You should be able to get all this done in class, probably, most of it. You really need to focus on practicing your slope calculation. So using that formula to calculate slope, as well as using a picture.